Hello and welcome, friends. My name is Shailesh Agrawal, Executive Director, Building Materials and Technology Promotion Council. And today I am going to conduct an interactive session on 3D volumetric precast concrete construction with industry experts who are actually employing this innovative construction system in the field, not only as technology providers, but also as construction agencies. Welcome, Mr. S.D. Vijay, Chairman Salman Leap India and Director Home Mission India, who a few years back brought the technology to India to manufacture, assembly, and install different building types. I also welcome Mr. Siddharth Sharma, who is leading modular buildings and precast product division of Messrs. LLP Limited, and they are the agency who is executing Lighthouse project at Ranchi using 3D volumetric precast concrete construction. So Mr. Vijay and Mr. Siddharth, I'm going to ask you commonly raised questions about the system, and both of you can give your response to them one by one. We are recording the entire session with the objective that listeners can understand the various nuances of this innovative system, and at the same time decode the prevailing misconception related with the cost, functionality, structural integrity, etc. Okay, so my first question to both of you is, when we have time-tested, proven cast in situ RCC framed wall construction globally accepted for low-rise and high-rise buildings, what is the need to bring this disruption? Is it worthwhile? You can respond.
Yep, Siddharth, you want to go first, Siddharth?
So you can go first. I'll add.
Sure. So, Doctor, of course, that is the most longest lasting method of construction, both the cost in situ and framework-based construction using the reinforced cement concrete. Now, we all know, while it is the most proven and longest lasting, with the pace of construction moving faster and faster to provide houses to more and more in the Indian context, you and I have been talking about how many million homes have to be delivered in a couple of years. That is what we have been targeting. When we have those kind of challenges, and before the 75th year of the independence of India, if we have to provide houses, obviously we need technologies which can deliver the same houses better and faster. So when it came to faster, particularly, we needed a technology which can adopt manufacturing of the buildings, which you and I are very fond of, instead of building the buildings. When we have to bring in the paradigm shift of not building the building, but manufacturing them and delivering a very large number in the shortest possible time, that was the key driver for bringing in manufacturing mode to deliver built environment. Of course, the other corollary issues are the dwindling construction labor, the a fast disappearing construction skills. Obviously, it's a very harsh activity for the human beings to be standing in the sun and undertaking. Increasingly, people are not inclined to continue with that kind of activity. So these were some of the demand side requirements of faster and more and better quality, consistent. And on the supply side, we had constraints of human resources being available, etc. Those were some of the drivers, which was very clear, written on the wall kind of a thing, which forced us to go look for this kind of a faster construction methodologies, manufacturing the built environment, which is proven in other geographies who do not have this scale of demand. They have been using it. So in summary, how do we deliver more in less time with better quality without putting human beings into very demanding work situations? That's kind of a broad summary, which it kind of pushed us to go look for these kind of technologies, bring it adopt it to Indian conditions and deliver, prove, optimize, etc., doctor, which we can talk in detail as we go forward. These were the key drivers. Over to you, Siddharth.
Yeah.
Yes, nicely put, sir. And I would like to only add, see, whatever we do, sir, we do to improve our current standards. And in construction, what we are doing from past, let's say 100 years in India, or let's say worldwide, we are still building the same way. And there is very less improvement in, let's say, with respect to the labor productivity, right? So that is why there was a need for this technology to improve the labor productivity, to reduce the number of steps in construction, right? So when we are casting 3D modules, we are reducing the masonry work, we are reducing the plastering work. So we are increasing the speed of the work by reducing the number of activity also and improving the quality as well. So I just wanted to add this.
Okay. Let's move to the next question. I have seen Mr. Vijay coming to me and struggling with different public and private agencies here and there, advocating the merits of this technology and working hard to promote it. Then came, this Global Housing Technology Challenge India, which was organized by Ministry of Housing and Urban Affairs. Was GSTC India a game changer to bring technology transition in the construction sector? And did it really help agencies like you? If yes, in what way?
Can I go first, Siddharth? Because I was involved in this from 2017. In fact, one of the first meetings I had with Dr. Agarwal in that conference room, it was full of about 35 people, who is who, whether Director General of PWD, Mr. Agarwal, the Secretary, the Joint Secretary, the NBCC Chairman. They all were there, And I had a crib until that day, because when we brought this technology and applied it in India, and the people who came and invited us to come and do the knowledge sharing was Government of Singapore. They invited us. I had gone there and delivered 3 lectures to Building and Construction Authority on how we adopted this technology, how we achieved a 980 rupees per square foot cost for the the superstructure. So, and obviously you see, other countries are coming and asking, how did we do? They are getting benefited. And, when is it going to happen in India? Good news is, within a few weeks of that thought crossing my mind comes the call from ministry. The secretary himself calls and says, here is the requirement from the Prime Minister's office, and I have just taken charge. Can you come and talk? And what began in 2017, if I remember right, we wanted to do something that year before August 15th. But by the time it culminated and climaxed into the Global Housing Technology Challenge, I am sure, Siddharth, you also would have felt a moment of redemption. We in India said, okay, we are no lesser than any other country as far as adopting the newer construction technologies. And yes, doctor, you gave us, at least me, a tremendous amount of energy. Your personal attention, the whole organization, the might you put behind the Global Housing Technology Challenge, possibly, in my opinion, for us, was the launching pad to launch the latest and the newest technologies into the Indian built environment. I would, say this here. I would say this in any forum. It was the launch pad. The Global Housing Technology Challenge was the launch pad for us to bring in these technologies and feel confident that we have the government at our back. Thank you.
Your voice is slightly, something you did to your mobile. So we are, getting, you have to enhance the volume of your this thing. Yeah, Siddharth, go ahead.
Yes, sir. So, in fact, with GSTC, it has started a chain reaction within the fraternity, builder fraternity, and let's say the engineering fraternity in India. And now people have started talking about these technologies. Earlier, nobody was even, let's say, giving it a thought, and they were busy in doing the conventional kind of construction. And the GSTC event has definitely given a big push to new and emerging technologies in India. And I would say not only in India, I think Saudi is following the similar kind of approach what we are doing in GSTC. And I have seen an article regarding China also following the similar kind of technology competition. So it is one of a, I would say one of a kind in the world that has happened with GSTC. And yes, it will give a big push to players like us who are fighting in the market to promote new technologies.
Great, great. Let's move to the next question. Mr. Vijay and Mr. Siddharth, what is the general perception of engineers and architects about the technology? Are they really willing to implement it? If yes, then why don't we see more and more projects coming up? And if answer is no, then what are the impediments, barriers which we all have to overcome?
So should I start?
Yeah, Siddharth, you can go first this time.
Sure. So basically, whenever we approach, let's say, a structural firm or an architectural firm, the question comes up with respect to the codal references or the work, existing work, what kind of work has been done currently in India based on these technologies, or what are the cost basis available for these technologies. So I think these are the questions which we need to answer, which we need to document. And I think this is one of the objective of GSTC, right, to get the codal references and cost basis in place once these technologies are performing.
Okay. Vijayji?
Doctor, acceptance of anything new is a challenge. You and I know that. All of us know, whether it is in life or work or technology, whatever. So when we brought this technology into the country in 2011, first 3 years was just building the awareness. Some kind of a Rambo thing we did, went around and talked to the people and we said we can do this, etc. We did not get projects. So the first project happened in 2015 when the Tata Housing Managing Director decided to fly into Australia and talk to people, see the houses. Then only he gave us the project. So that was a lone ranger kind of an approach. It would have taken, I don't know, years, or it would not have taken off at all. But today, in 2021, I can tell you, the stakeholders are obviously the regulatory agencies, particularly the government entities. They needed an endorsement. They needed a reference document which will tell them, okay, go ahead and use this. If you recall, Doctor, when you put in your effort and brought out the schedule of rates, which could be published for these kind of technologies by coordinating with PWD, I think that was the first big shift that came about as far as the government and regulatory entities are concerned. Once the schedule of rates were published for precast, however refined or not yet refined, it could be, but the fact is it came about, and that brought in at least an willing to look at kind of a mindset change. That's number one. So like Siddharth was saying, then came the practitioners, the professionals involved, the structural engineers, the architects, those people. For them, bringing in something new was a challenge. These people did, hesitate in the beginning, but some of the, early adopters came in and moved. And the GSTC, again, because you involved those people, at least made them wake up and say, maybe I should look at these kind of technologies. It is good for my practice as a structural engineer. It is good for my practice as an architectural firm. Those things happened among the top firms of architects and structural engineers. But, the biggest mileage or the acceptance that is coming is the course which you are running, the Navriti. That is taking it from top, only few people being aware, being the path breakers. You are suddenly making it broad-based. You are, building what one can call as a ground swell. A ground swell in a market of this size is a very difficult thing to achieve. And I think GHTC, followed by the Navriti, is kind of doing whatever is the key requirement people like us have. The Columbuses always need backers. If Columbus could discover another continent, there was a king behind him who funded and pushed. And I think if we try to be Columbuses, lone rangers, I think it is the force like the ministry and your effort and the GHTC and obviously the Navriti and this one, Technograhis, is going to be the game changer. I think we one day could stand up and say proudly, bringing about a change is a challenge. Bringing about a change in an industry like construction is almost impossible thing. And this is how India did. It could become a reference. It could become a case study for other countries, is my hope and prayer, Doctor. And yes, we still have challenges, but I think we have broken the inertia. We have started the movement. The momentum should follow, is my hope and prayer, Doctor.
Let's move to next question. I think Mr. Vijay was first to coin this that let's not construct buildings, let's manufacture the buildings. And I immediately supported it. And I have firm belief that in times to come, we will manufacture buildings. So the next question is related to manufacturing of buildings. Down the line, do you see its future in India? Can we buy a house from the factory and install it at our location? Both of you.
Siddharth?
You can start. I'll add.
Okay, sure. So Doctor, as we, in our private conversations, we have been talking, a car may cost today 5 lakhs to about 5 crores. A house, again, at the lowest can be 5 lakhs and 5 crores. A vehicle which lasts maybe 5 years or 10 years is available with the global standards for anyone to pick, choose, customize, add extra fittings. Thanks to the industrialized approach, these units are produced with, manufactured and delivered through a network. I do believe, I don't know whether it will happen in my lifetime or not, but I do believe that is the next stage. The built environment will be a manufactured product delivered to the end user with the requisite amount of customization. He could, in time to come, place the order. And it is not new, like Siddharth in every lecture keeps talking about. Precast is more than a couple of centuries old. It's just that it was not broad-based. And this approach of picking up the phone, placing an order for house was as old as Sears, about 50, 60, 70 years back. Sears had a mail order house. So we would possibly converge all of that into a broad-based default system where anybody who needs a place to live would first priority would be to go place an order and get it delivered. That is what I believe. And I think, these little baby steps we are taking, moving the mountain kind of effort we are doing would take us there. And it would be a manufactured product too. Maybe Indian standards, which will become global standards, is what will be the future. I don't know how many years it will take, but we are definitely going in that direction, Doctor.
Thank you. Siddharth?
Definitely, sir. I think it has already started. Vijay sir is doing that. He has a website wherein people can order homes. Yes. We also did similar effort in Western India, and we started that with 2D precast, and we realized the need of 3D precast because still finishing was happening at site. So that's why we started exploring volumetric construction and modular construction. And definitely we see that the individual home industry will also evolve towards ordering a home from a website and getting it done quickly, let's say 60 to 90 days period.
Okay, now let's move to the questions related with use of technology. And both of you know the most important one is the cost. So cost in comparison to conventional RCC construction. Also tell us about the critical mass. That is minimum number of units required to make project economically viable.
Sir, you can start.
Yes, Siddharth. So Doctor, we needed to put slight boundary conditions or definitions to the cost. When we say cost, and whether the pre-cost technology can deliver the built environment at comparable cost, same cost or lower cost is what we need to delve into. Let's talk about cost. in conventional, which essentially means the framed structure, or cost in situ, I want technology based. Let's take this as a reference cost and say whether precast can deliver it. Precast again comes in two ways. One is on-site manufacturing, other one is off-site manufacturing. Most of the two-dimensional precast or elemental precast production tends to be off-site. In an off-site scenario, you beautifully touched on the point, not only the cost, the minimum critical mass. While the cost can be matched if the scale is there, the minimum critical mass is what becomes a challenge when we are doing off-site in the 2D or elemental precast kind of a thing. Now, let us move from there to 3D monolithic volumetric precast. In the case of 3D monolithic volumetric precast, as Siddharth is already doing for the Lighthouse project, as we also are doing currently for the Goa New International Airport, we have not set up the production as an off-site facility, but we took the production facility to the site. Hence, I do not have to incur the transportation cost, which is a big load as far as the precast is concerned. Second thing we did was, like in the introduction, you talked about modular housing. Not only the houses are made with modules, the business model, the factory itself is modular. Siddharth and I can go to the site with one machine, which makes one room a day, or we can go with two machines, two rooms a day, or if the project size is big, we could go with 10 or 15 machines. And hence it is scalable. So what is the minimum size of the project I need? It could be as low as 200 to 300 square foot production a day, which means one machine. It could be 3,000 square foot a day, which means 10 machines I put. So this modularity is not just at the building manufacturing. The manufacturing facility itself is modular. So in addition to other barriers we are trying to break in the construction, we also have broken this barrier of minimum order quantity by adopting A, on-site production, B, bringing the machines themselves as needed, one machine or two machines or 10 machines or 20 machines. Hence, both not only the connection and the leakage and seepage issues, 3D monolithic modular by its inherent nature, removes those challenges. It also removes the challenges associated with, what is the minimum order quantity I need? Siddharth just mentioned to you, we deliver individual homes from a facility in Ultratech RMC plant in Bangalore. So you want one house, I'll deliver. You want 1 million square foot to be delivered, I'll move my factory to the project site and deliver. That's what Siddharth is doing in the Lighthouse project. So, to summarize, Doctor, we can match the cost if the scale is more. If the scale is less, we move the factory to the site and save money. And if it is distributed demand, we position the factory in a central place. It can cater to a radius of 30, 40 kilometers. And that way we get the requisite demand. So these are the things which we have discovered as we, travel the path in Indian market, Doctor. Siddharth, over to you.
Yes.
Sure, sir. I think rightly covered. The minimum order is now almost gone away with the off-site, on-site kind of production. So we are following off-site methodology, but doing an on-site plant, right? So, but still, let's say if there is some cost difference, let's say 10-15%, but that is like that will not be there when you see the total own cost of the construction. Right. Time is also a very important cost which generally people don't count. So if your projects generally gets delayed, most of the conventional projects get delayed. And if you aim to finish them on time, definitely you will save a lot on your fixed cost, and also on the, let's say, interest cost if you are taking a loan for developing the project. Right. So these are the two major costs which are saved by using these technologies. which generally people don't count, but they add a lot if counted. Almost 300 to 400 rupees per square feet is a number that we have identified these two costs can contribute to.
That's very good. Okay.
Yes.
That's very good. Okay. The next question is about structural performance of these buildings in comparison to conventional RCC construction. What's your take on structural performance of these buildings in comparison to conventional RCC construction?
Siddharth, you want to go first or you want me to?
So you can start.
Okay. So, Doctor, when we talk about the comparison between conventional RCC buildings versus 3D monolithic modular precast buildings, the fundamental thing is, be it conventional RCC framed structures or cast in situ RCC structures or 3D monolithic modular precast, the common is the same material. It is the same concrete, it is the same steel. And then comes the question of, okay, each element that you manufacture may match the other two categories. How about the connections or the joints? Are they the weakest link, dictating the overall structural performance of the building? And we have discussed this in the courses again and again. Today, we do have manufactured structural connections which have gone through the rigorous testing, which is applied in the infrastructure space, which carries much, much higher order of magnitude, higher loads, whether it is a metro, whether it is a flyover, where all the elements are precast, and the connections in those elements are done by these manufactured connections, whether it is a column shoe, whether it is a grouted connection, whether it is a bolted connection, or any other new form of grout couplers. All of them are tested, proven. And we are only adopting, in addition to the strength of the proven concrete and steel, we are only adopting these tested, proven ones, which are performed in far more demanding circumstances, adopting it to a lesser demanding environment like building. The proof of the pudding is, obviously, has there been a tall structure? Yes. 41-story. We all talk about it again and again. Has it been tested in different seismic zones? In theoretical sense, in the lab conditions, yes. And in terms of modeling, the same structural modeling we do, whether it is the ETAB or the SAFE or finite element analysis, what we do. And again, good news is, like Siddharth was bringing it up upfront, the structural engineers who were, earlier not very confident, today enjoy doing the structural design for volumetric construction or modular construction or 3D construction in India. You should see the enthusiasm of the IIT Roorkees. Doctor, I would again go back to GHTC. It is you and the Ministry of Housing, by doing GHTC, by bringing these august institutions as part of this, you kind of triggered that. Today, when I pick up the phone and talk to IIT Madras, IIT Roorkee, or anybody, I'm not a stranger. I don't have to introduce. They say, oh, 3D, yeah, GHTC. Let's go. Let's do this. That kind of opening the door has happened. Hence, structural engineers are able to design. When they design to implement it, whatever is the kind of connection required, they are able to get the supply chain side. And hence, the structural performance of these 3D kind of a 3D monolithic volumetric precast building, I would dare say, can perform better than the other forms of construction.
Siddharth, you can continue, please.
You must have lost me for a minute. Yeah. So this one can perform better than the conventional, the framed, and the cast in situ is my belief. Obviously, it has to be validated by experts like you, Doctor.
Wonderful. Siddharth, would you like to add something? Being engineer yourself.
Yes. So, like Sir said, there are now connections available in the market, and the design is like you design in the same way how a conventional building is designed. And it is just that we are resolving the joints in the building, and those joints are properly detailed and are good enough with factor of safety to take the loads which are coming on those joints, right? And Then these buildings are also tested with P delta analysis and for progressive collapse kind of scenarios also. And now I think there is a IS code also in India, so that there are guidelines for design now, and definitely these are much more stable buildings compared to conventional, because the quality with respect to what we achieve in conventional structures, right? We might design something, but what quality we are achieving at site is a big question, right? Compared to what we are manufacturing in a facility, in a factory kind of setup is much higher, and we can be assured of what we are designing, and that is what we are building or manufacturing. So that gap between design and what we are executing is being filled by this technology. So that is also one of the greatest points.
I think you have put it very well. Yeah, I think my next question you both have answered, but again, just for the sake of reaching out to the techno guys, I will just read that question, and you can just add a bit in that, because that is also a question being asked in every forum wherever we talk together. It's about joints and connections. As you put your module over one over other, then in the event of an earthquake or little ground shaking, if structural integrity and monolithic behavior of joints are not ensured, these modules will fall one over other. I know both of you have different systems for joints and connection. So how do you address this?
Siddharth, I think you should take it, because we have talked about it again and again. Go ahead.
Right. So like we were just discussing right now also, like we were talking about progressive collapse, right? So these buildings, before even we construct, we tested for that kind of scenario. We do P delta analysis also, so to understand, like when it is swaying, there will be additional force because of the shifted CG of the building, right? So all these forces are taken in account, and then these connections are designed for that scenario. So definitely, if if a earthquake happens, these buildings are capable of taking those loads.
Well, Vijayji, I think you have addressed it, but want to add something briefly?
Yes, doctor. Like in the previous question, we talked about the type of connections and the strength of connections is standardized, tested, applied to for higher loads is what is being today brought into the built environment. What was in infrastructure is being now applied into this area. So, the connections are proven. The infrastructure elements do stand after earthquake. That is the kind of a proof of the pudding from the market, from the, site scenario we can convey. And obviously it is all now with whatever is the proficiency we have in structural engineering design. Our structural engineers are able to apply those things and test it for various scenarios. Progressive collapse, all of us talk about, and it happened in one of the precast buildings done post Second World War time. And that has become a case study, and it is etched in the memory of everybody. So everyone automatically, as a hygiene factor, checks for those kind of downsides before they sign. Yeah, that is already there.
Yes. Okay. Shall we move to next question?
Yes, sir.
Yeah. Okay. Yeah. Not audible, Vijay? Yeah.
Doctor, we can go ahead.
Yeah. See, the next question is about, because these modules are thin concrete walls, does thermal comfort is compromised in this technology? Siddharth, you can go first.
Sure, sir. So the behavior, like if we are constructing with the, let's say, L-form technology, right? So once the building is constructed and joined, the thermal behavior of both the buildings will be the same. And I think most of the high-rise buildings are being made with the L-form, or let's say shear wall technologies these days. So I would say the thermal comfort is almost same. Plus, to let's say reduce the heat transfer, we can further use reflective plates on the external surface of the building. Also, we can do some experiments with respect to the density of the concrete, so that we can increase or decrease the thermal conductivity to, let's say, improve the indoor conditions. Also, see, these things can also be addressed by properly designed architecture and, let's say, cross ventilations also. So those things, if we design it holistically, then definitely there is no such issue of let's say these buildings are overheated or such kind of scenarios.
Okay. Mr. Vijay?
Yeah, doctor, we talk about thinner walls. That is the first thing we talk about when it comes to 3D kind of a thing. It is not a thinner wall. If we apply in my one or cast in situ, if that is 125, it is 125 here too. So the thickness or the thinness of the wall remains the same. And if it is a taller structure, if we have to go with 160, we go with 160.
Exactly.
In my one as well as here. In my one is full concrete wall. Here too is full concrete wall. So in terms of the wall thickness, in terms of the material that has gone into the built environment, they are same. Hence.
Yeah. Okay.
So, yeah. Hence it will be the same. And these technologies are used extensively in countries where it is mandatory to provide thermal insulation. It is happening, whether it is Australia, whether it is Middle East, whether it is Europe, where they have said the external envelope of the building necessarily have to be meeting these thermal requirements. They're used. It's only a question of whatever they do to add the thermal comfort inside the building can be afforded by us. They add a layer. At the time of pouring, they could add a layer of thermal insulation inside. We can do that technologically. Commercially, whether we can afford it, that is the only question. In fact, particularly when we go into manufacturing, whatever you need to add, you can add. Whether before the pour or after the pour, you can add. Because like he said, it is made in a factory, you have all controls in it. And it is not labor driven. So you can add it. So again, I see an advantage by going for these kind of technologies as far as the thermal comfort is concerned and meeting the challenge of thermal comfort is concerned, Doctor.
Great. Okay. The next is, does the technology comply with fire rating given in Indian standards? And what fire rating you claim?
So basically, the structural members are 2 hours fire rated, sir. Okay. And non-structural members are basically at least 1.5 hour fire rated. So that is what we are currently following. Okay. And you can achieve this by either increasing the wall thickness or by increasing the steel. That depends on architectural design. So basically, if you want to give a 2 hour fire rated, then minimum 160 mm wall thickness is required, so that we are giving for load bearing members.
Sure. Mr. Vijay?
Yeah, doctor. It is the same codal thing. It is a concrete.
Yeah.
So what works there works here, and it has to be adhered to. It is being followed. Okay. So fire rating is like thermal comfort. Fire rating also is very, very similar to.
Okay. What about service life of building with this technology?
So I think, like in Navriti presentation, we have shown buildings existing more than 60, 70 years now. So okay. I think, and they're still running. So we can take this as a practical example, right? So it is more than 50 years.
Yeah. Yes. Yeah. I think Vijay has gone. So let me move to next question with you, Siddharth. The next question is about being entirely precast concrete construction. How do you justify this? Okay, Vijay, you are back. So I was just asking Siddharth about the service life. So he answered it very well that already buildings are existing for more than 70 years. So that is the testimony to the technology. Would you like to add something else into this, Vijay? Mr. Vijay?
Sir, you are on mute.
Hello?
Yeah, Vijay. Yes, Mr. Vijay.
You hear me?
Yeah. Sure.
Yeah, go ahead, Siddharth.
Yeah, the question was about service life of these buildings.
Siddharth, you are answering or you want me to answer?
Sir, I have answered.
Yeah.
Okay. Service life is, the same answer, doctor. It is as similar to other forms of conventional RCC construction. It's the same life, the same material, same life.
Okay. We are not able to see your face. We are seeing green ground. Vijay, Mr. Vijay.
Go ahead, doctor.
We are not able to see you. Rather, we are seeing I think a picture of your ground.
Yes. Yeah, it is. I'll just turn it off. I'm trying to do that.
No issues.
Yeah.
So the next question is, Siddharth, being entirely precast concrete construction, how do you justify this technology to be environment friendly, energy efficient?
Environmental friendly, yes, because there is no pollution at the site, and there is no, let's say, suspended particulate matter being polluting the site. There is no major noise happening on site, right? And with respect to energy efficiency, I would say we are going towards a more productive method. So definitely it is much more energy saving compared to a conventional construction.
Yeah.
Though we are using more machinery, but if you said total embodied energy, definitely it will be lesser than conventional construction.
Yeah, that's very nice. Yeah, because productivity. You talked about productivity. Vijay, are you there, Mr. Vijay?
Doctor, I'm here.
Yeah. So my question was, being precast concrete construction, how do you justify this technology to be environment friendly and energy efficient?
Yeah, doctor. So, multiple ways. I think Siddharth has already covered the reduction in wastage. And if you look at our factories, we do not go around splashing water to cure. Reduction in water usage.
Yes.
Again, all your centering material and form work where you use extensive amount of wood and wood products, we do not use. So plus in terms of safety, we are manufacturing in a factory condition that again kind of saves, adds to the safety and reduces the risk. And in terms of the overall material we use in this kind of newer manufacturing methodologies, there is a certain amount of saving in material, despite the fact we use machines, despite the fact we use a little more of energy. Net to net, I believe this offers far greater productivity and thus, puts less demand on the resources that are used. And in summary, is what adding to the sustainability is all about. In that sense, we are, again, a little better off than the other older ways of doing things.
Okay. So let's move to the next question. How do we carry out maintenance of services, that is water lines, electrical cables, sanitary installations, sewerage, once the building is put to use? Do you train people or have SOPs?
Sir, let's say it is the training of people is more important during the erection, and let's say once the connections are made, the building is same for servicing as compared to a conventional construction, right? So there is no major change that will happen that a normal electrician or a normal plumber will not be able to address it. So it is just that during installation or let's say during erection, we need to do some connections, and post that, once those are established, once the wires are run, or let's say the plumbings are connected with the main pipeline, so then there is no difficulty in maintaining it.
Vijay, like to
Yeah,
add?
in simple terms, doctor, in the normal framed structure, we do the frame and then bring the block work or the bricks, put the wall, and then we call the tradesmen to etch the wall and create the paths for be it conduiting or for plumbing lines. In our case, these things are in the 3D monolithic precast. These things are first installed before we open the concrete, which means the structure, the module comes out with pre-embedded electrical conduits, pre-embedded pipes, or pre-cast grooves for placing the pipes. So that itself saves time. Like Siddharth upfront was saying, it is not done in a multiple step after step manner. It is a batch processing at one go. You are compressing a lot of things, including the trades like electrical and plumbing, at one shot you complete. Now, question is, hey, I have done this, but I need to change the line. I need to add a tap. How do I do that? Just as the mason or the plumber or the electrician would go into a structure, cut whatever is the surface. It could be a brick surface, it could be a hollow block surface, or it could be a Maiwan cast in situ concrete surface. Today, we do have the masons with the tools. They come in, create the path, because as long as the concrete cover can provide the required depth for the electrical conduit or for the plumbing line, we can do it again, similar to what is being done in the case of framed structures or in the case of cast in situ. Only thing is, in this case, a tradesman with the tools would be a better option. So that is how we have experienced, in now the current project we are doing in Goa. Like you said, whether we need to give them special training. In fact, the existing tradesmen, the workers, they say, "ये तो बहुत आसान है. ऐसा करने से तो जल्दी हो जाता है." That is the kind of feedback one gets from the workers and the tradesmen themselves, Doctor.
Okay. Let's move to next. What codes, design aids, softwares are being used to design and construct these modules and buildings?
IS codes, ASTM codes, and PCI handbook for, let's say, some detailing of joints. And for example, we are using ETABS for modeling and for foundation starts.
Okay. Vijay, Mr. Vijay, would you like to add something?
It is the same set. All of us have to use, and whether it is Siddharth or us, or even other precast people use it. But increasingly, Siddharth also is using it. I suppose we are going more and more and more into BIM. Because BIM helps me to make sure before I open the concrete and pour it, everything is taken care of. There are no clashes. There is not too much of a repeat work. So BIM has really started adding value, or we have now got a methodology where we can exploit the full potential of BIM, Doctor. That is the additional one that comes in.
That's right. Okay. I think that was all about technology, and just for the sake of techno guys, I will ask few questions about manufacturing of these modules and their transportation and assembly, so that you can explain to them that how these things are being manufactured. So there are in fact 3 questions. I'm clubbing those 3 questions, and both of you can take your time and answer them. The first one is, how do we manufacture these 3D modules? One. Secondly, what kind of equipment and machinery required? And the third is, if it gets damaged, do we discard the module, or can it be repaired? So how do we manufacture? What kind of equipment, machinery required? And if it gets damaged during transport or during assembly, do we discard, or can we repair it?
Siddharth, you go first or I go first?
Please, you can answer.
Okay. So number one, how do we manufacture the buildings or the modules?
Yeah.
It is a mold made out of steel plates and steel structural elements, which are operated with hydraulics, and that in turn is controlled by a system which is remote control operated. It's there in the public domain, whether it is Siddharth's video or our video. You can see what does this mold look like and how it moves its elements to take the concrete and take the reinforcement, then take the conduiting, then take the concrete, and how does it cure? There is a built-in curing that is there inside. And obviously, when we are curing, we have the sample cubes inside. There is a provision for that. And we take out the cubes to check for the strength. Next day morning, if it has reached the requisite strength of anything around 12 MPa, we can demold. So push the remote, open the doors, bring on the crane. That's where the other equipment comes in. we do use gantry cranes if it is on-site factory. If it is not a large factory, we can use the same hydraulic crane for manufacturing and also erection at the site. So it could be a gantry crane taking care of a few molds, or it could be a hydraulic crane, both for demolding as well as for erection. And what do we do? How do we transport? We prefer to do it on site. And hence, the movement of the module is from the casting yard to the building site, which is normally next to each other. And what do we use for transportation? A normal flat bed trailer. Even a semi-low bed trailer is fantastic because inside the site, only you are moving. So you use a normal trailer. And if the module width is broader, we add what is called as a transport beam, which is placed on the flat bed of the trailer. And on top of that, you put the module so that it doesn't suffer any damages. In the worst scenario, if there is a damage that has happened to the module, we obviously need to take up a study of whether it is a structural damage or not. If it is a structural damage, then the question is it a repairable structural damage? Invariably, these elements so far in multiple countries, it has been manufactured. The structural damages are almost very, very less. In Australia, they move these modules on the road for as long as much of 600 plus kilometers. And we haven't had challenges transporting the modules. Of course, the road conditions there may be slightly better than what we have. Repair work, like whatever repair we can do in other forms of concrete structure, is doable here also. Siddharth, over to you.
I think manufacturing process, sir has explained nicely. I'll add to handling part. So while handling, we need to avoid, let's say, additional torsional forces on the casted elements. So it is designed for lifting loads, transportation loads also. So we use pre-designed lifting frames, which are, let's say, of the size or shape of the elements that we cast, so that there are only vertical forces on the casting, right? So that to almost, let's say, 90% of the chances of failure of our module, or let's say coming cracks in the module, are eliminated by lifting and handling the elements properly. Transportation frame, going beyond the so that there's the like sir said, if it is a structural failure, we need to discard it. Surface crack, like we.
Siddharth, your connection is slightly unstable now. Siddharth?
Yeah. Siddharth, your connection was unstable. I could hear bits and pieces. Essentially, Siddharth is conveying, I am just stepping in because his connection is a little feeble. So he's saying, yes, in addition to whatever I said, he has the provision to control the torsional forces on the module. Hence, he uses a lifting frame so that the torsional forces on the module are minimized. And if when we transport, if the damage occurs, whether it is a structural damage, if it is, and then we need to discard. If it is a surface damage, however, the way, normal way which we repair any other form of concrete structure is what is applied for here also. I don't know whether I correctly captured it, Doctor.
Well, wonderfully.
Yes,
I think the next is what special traits, skills one has to learn in order to implement this technology in the field. What special traits, skills one has to learn in order to implement the technology in the field.
So you would like to go first?
I don't know whether they are special traits. The skills are, each of the engineers taking care of each side of the module should be able to read the drawing perfectly and sign off saying, as drawn is what will be produced. And there won't be variations between as drawn and as produced. That is a skill set we insist upon, and we hence employ engineers to, each side of the module is taken care of one engineer backed by the Polytechnic guys. That's what we do. And other than that, special trades, nothing is coming to my head unless Siddharth, do we need any special trade?
No. So only thing that we need additionally is we should plan and then execute rather than execute and plan.
Okay. See, the next one is, I think there are only few left. They are more general questions. In the wake of, Atmanirbhar Bharat and Make in India campaign, and we have been talking about that this technology comes from abroad and all. What are your plans to train the workforce available in India?
Sir, can you repeat the question?
Yeah, in the wake of Atmanirbhar Bharat and Make in India campaign, what are your plans to train the workforce available in India?
Right. So I think in current Lighthouse Project Ranchi, we are taking, with the help of state governments, we are taking few local laborers to skill them up with to this technology, and then maybe employ them in the project. So this was one of the aim of Lighthouse Project also. So that is what we are doing, and we generally keep taking freshers from ITI, and we keep training them on these precast and 3D precast technologies. So we are already doing that.
That's very nice. Vijay, Mr. Vijay?
Yeah, Doctor. Atmanirbhar Bharat is actually much needed one, which we now have officially institutionalized. When we brought in this technology, I was thrown out of every client's office because of the cost that this was costing per square foot. So the first few things we had to do if we have to get into Indian market was how much of this mold can first be manufactured in India. How much of the manufacturing cost can be reduced by adopting Make in India? That was the first thing we had to do. So today we are in a position to manufacture these patented molds in India with a cost advantage, which helped us to get a little bit of a breakthrough into the market, number one. Number two, the Indian engineering talent is known to you, known to most of the world. So now we also design these molds for the global market of our partners in India. So design and manufacturing of the mold, except some of the proprietary items which they do not want to share with us, all other things are being done in India. And if I don't know whether that is part of the Atmanirbhar Bharat initiative. Coming to the training the people and skilling them, we do similar thing, but with a slightly different approach. What we felt from 2015 onwards, when we go to the government engineering colleges in remote locations and pick the engineers fresh from there, the open-mindedness, the enthusiasm, the keenness in them is something like a magical power. And that is what helps us to ramp them up. We delivered, we kind of trained about 40 captains. Each captain takes care of a mold, which means he can deliver about 300 square foot, a team of 4 of them. We trained 40 captains capable of operating 40 molds in a matter of 6 months. That is the speed with which we are able to train the people in the Goa project now. We are taking people from different states because it's a large project, already existing labor force from Jharkhand, from Uttarakhand, and from southern states. They're there. So it's a fascination for them when they see in the same site, airport site, building is manufactured. They kind of gravitate towards this, and they do show a lot of interest. So we're able to train engineers. We are able to train the Polytechnic people. A lot of ITI gentlemen are coming in now. So yes, the training is happening, but on a need to have basis and at site conditions, not as an institutionalized training as yet, Doctor.
Nice. The next is, I'm sure this conversation, the session which we are having will be seen by budding engineers and architects. And if they find it exciting and wish to make this 3D volumetric construction as their career, what should they do?
Obviously, they can reach out to any one of us through you, or they can reach out to any one of us through the site. So thanks to you, it's all in the public domain, Doctor. Anyone, anytime can reach out. And my number is with you. If you would like to share the number, please go ahead and share the number.
Siddharth, would you like to add something? Do they need to acquire some special skills or something? Engineers and architects, if they want to do some consultancy in this kind of...
Only change of mindset is required, nothing else.
Very well said. Very, very well said. Yes.
Okay,
yes.
So the last question now is, at present, there are very few agencies in India who work, on this new technology. So the question is how it can be scaled up to bring more and more players in the arena so as to cater to growing urban needs of housing and infrastructure.
Siddharth, you want to hear a dream or you want to share your dream first?
Yeah. We would like to hear you first.
Okay, so doctor, here is the dream. Like, people should go into a showroom or get into a website, order their homes. We talked about a few minutes back.
Yes.
So the dream here is we should have at least a couple of built environment manufacturing factories or facilities or yards in every single district capital. Every single district capital is what is the goal. Now, if we have to do that, obviously it has to be broad-based. What we have done is we have kind of started talking to the engineering colleges and the finishing schools to get that momentum going, but it is in preliminary, early stages. We don't have the muscle power to reach there, but like we did with the Global Housing Technology Challenge, like you are doing with Navriti, if we can join hands and go for taking it to a broad-based level, the technology is available, the technology owners are open about it, we can create a network and do that, doctor.
Okay. I think that was my last question. Before I, say thanks to both of you, if something I am not able to ask you or is not covered, both of you may say something. I mean, if you want to add something to our conversation, which will add value to whatever we had in 1 hour or so, you can just give your last, sentences on that. Vijay and Siddharth. Anything you want to add in addition to what we discussed? Siddharth?
I think you missed the efforts that you guys are doing, and to let's say promote this propaganda of new and emerging technology, right? So it's a very, I would like to add that it is a very good initiative, and we were trying from almost 5 to 6 years to penetrate the market, but I think this step taken by the ministry and our Prime Minister and your department is definitely doing the job. And also the number of players are increasing, and when we started there were I think hardly 10 or let's say 15 precast players in India, and now if you count, I think every state is having one precast player, and the number is beyond 50 now. So it has gone almost, let's say, 3 times, and I think with the efforts that you guys are putting in, it will definitely go exponentially in future.
Thank you, Mr. Vijay.
Doctor.
Yeah, now you can switch your video also, because
no, unfortunately my camera is going to the other side. I don't want to get I didn't want to get distracted, so I turned it off. So doctor, the milestones in your effort, in Government of India's effort, has been the global housing, other than the seminars we used to run in multiple states, where we used to go and promote newer precast and newer manufacturing technologies, culminating in Global Housing Technology Challenge, followed by Navriti, followed by what we are talking now. I think one thing we forgot to mention is how you and Government of India together have created the Technology Innovation Grant. The Technology Innovation Grant being made available to a very targeted initiative like the Affordable Rental Housing Complex. That, I think, would be the next big inflection point, taking it to a newer high, is my reading of the market. And maybe, without putting too much of effort, these things will pop up. More such initiatives will pop up. Like you said, this thought that we could have a conversation which can go onto the social media. It occurred to you, ab initio on its own. Same way, there are other things which will pop up. I expect that right now we are working with the state governments, and I think it will percolate down to the district levels, should be the next one. If we really have to push, we probably have to take it to the district level entities to say, hey, this is the new technology, whether you want a precast block, you want a precast element, you want a precast building, you want a precast hospital, you want a precast school, not only in housing, in all the forms of social infra. Again, these things can come in. And with that push, it would truly get broad-based. And our goal of shifting from building the building to manufacturing the building will become de facto, first choice, default choice is what, comes to my mind because you asked me this question. Let's see, doctor, we will respond and keep moving forward. That is what we believe. And thank you for all the support, doctor. And without you, I don't think we would have come this distance. We would probably be walking. You helped us to run.
That's my job. Siddharth, you want to say something?
Yes, sir. I think we are moving towards, let's say in coming 5 years, we're moving towards, like we will be selling building components.
Wonderful.
For example, columns, beams, staircases, slabs. Currently, we are installing them because people are not aware, but down the line, we see there will be contractors available in the market who will be asking for components, right? And we can move towards a standardized kind of solutions for every kind or type of buildings. So that will definitely productize the construction, which is currently a service sector as of now. So that is what our vision is, to productize the construction or manufacturing.
Okay, so with this, we come to the end of this lively session. I am indeed grateful to both of you. I mean, from the bottom of my heart, all the time you both guys are available and always answer, even silly questions being asked, you are answering everything so passionately and so technically. So I'm indeed grateful to both of you for being part of this lively session and respond to the queries elaborately. With agencies like you who have passion to change the construction sector in India with these cutting edge technologies, I'm sure that very soon 3D volumetric construction will be the technology of future construction in India. And we will become global leaders in the area of innovative construction technologies. So thank you very much. With this, I sign off and will come again with another session on other new technologies with other experts. Thank you very much.
Thank you, doctor. Thank you. Thank you from Home Mission. Bye.
Bye.